Welcome to the supplementary lecture entitled Only Controlled Experiments Can Prove Cause. Subtitled, Does Mozart Really Make You Smarter? This lecture is centered around the principle that observational studies cannot lead us to cause and effect conclusions. There was a controversy that arose in the 1990s as a result of several studies that suggested that children receiving classical music education were stronger academic achievers. The Wikipedia article on the Mozart effect seems to offer some support even now for this idea. The origins of this myth, however, lie in the 1950s, when an ear, nose, and throat doctor, Albert Tomatis, claimed that listening to Mozart helped people with speech and auditory disorders. A later study at University of California, Irvine in the 1990s reported that IQ scores went up by as much as 8 points after people listened to 10 minutes of Mozart before taking the IQ test. Then an enterprising musician named Dan Campbell trademarked the phrase the Mozart effect and began marketing books and CDs supposedly to raise the IQs of babies. Some public officials then got involved, suggesting that we allocate public funds to buy every school child classical music recordings. Sadly, there is no IQ test necessary to enter politics. Well, mere listening to Mozart music probably doesn't increase IQ. However, there is a pleasure effect in IQ testing. We know that people who take IQ tests immediately after almost any pleasurable experience tend to do a little bit better. There was another thing that was confused in the debates of the 1990s, and that is that listening to classical music isn't the same as learning to play it. So lots of things do tend to improve mental ability. For example, if you get enough exercise, whether you eat a good diet or not, whether you have adequate sleep. For that matter, even having a pushy mother is very likely to improve academic success. So how do we explain the studies of the 1990s that correlated classical music education with general academic success? Well, first of all, in any large observational studies, it is not very hard to find correlations. You simply collect a large amount of data, you find any two variables that tend to go up and down together, or maybe when one goes up, the other one tends to go down, and then you pretend that one of them causes the change in the other. But the logic is deeply flawed. If we have two variables, say A and B, this correlation leaves open a number of questions. For instance, is it the case that the changes in A cause the changes in B? Or maybe it's the other way around. Maybe changes in B cause the changes in A. But in fact, there could be yet another possibility, and that is there's another variable that causes both A and B to make whatever changes they're making. Indeed, there are more explanations than this available, but it's this last one that we really want to focus on. Could there be another variable that's causing the changes in A and B? Such variables are called lurking variables. You see, a lurking variable is a variable that influences outcomes, but it is not itself measured. The term lurking is intended to suggest the idea of someone or something that's hidden in the shadows or maybe around the corner. It's important, but it's not seen. So, what's the lurking variable in these correlations? A study of school children found that reading comprehension scores correlated with shoe size. Does that mean we should stretch children's feet to make them better readers? Oh, I don't think so. Another study of shark attacks showed that the number of attacks are correlated with seaside ice cream sales. Maybe we should prohibit ice cream sales in order to prevent shark attacks. Well, clearly not. In both of these cases, there's an obvious candidate for a lurking variable. In the case of school children, as children get older and as they receive more instruction in reading, their feet grow and their reading comprehension scores improve. So the lurking variable in this case would be maybe A's, maybe years of instruction. In the case of shark attacks, the obvious lurking variable to consider is simply the weather. When the weather is fine and hot, people go to the seaside where they both eat ice cream and they get in the water. And remarkably enough, there are very few shark attacks on people who are not in the water. We should always consider the possibility of lurking variables when we are interpreting observational studies. Now, this does not mean that observational data could never suggest to us a cause between one variable and another. It's simply that it doesn't prove it. We have to consider the possibility that there is yet another explanation. It may not be that one variable that we studied causes the changes in another variable. So let's get back to the Mozart effect. There are many possible lurking variables when we think about these studies. First of all, there's the general socioeconomic level of the children who are studied. Do they come from wealthy homes? Do they come from poor homes? Do they come from middle-class homes? What about their parents' commitment to education? How about the family's general level of function or dysfunction? What about the child's individual and intrinsic motivation? You see, there's simply no way that we can separate out the cause agents in these studies. It is simply true that talented, privileged, and motivated children are more likely to do well academically, and at the same time, they are more likely to be exposed to classical music. So it isn't surprising that academic success and classical music exposure tend to go up and down together. In summary, we simply cannot make cause-effect conclusions from any observational study. A lurking variable may be hidden, which is causing the effects that we see. We can make cause and effect conclusions, on the other hand, from a controlled experiments. The reason is that proper experiments control for lurking variables. That's why the control group is called the control group. In principle, with a good controlled experiment, the only difference between the control group and the treatment group is the treatment that is applied to the treatment group. There are no lurking variables because all other conditions are the same for both groups. So then, how do we determine causes? The answer, of course, is with experiments. What if we wanted to know then whether listening to classical music actually causes an improvement in academic outcomes? Could we do that with an experiment? Well, yes, we could, and it would look something like this. First of all, you'd want to implement the principle of randomization. We'd select a random sample of children, and then randomly again, approximately half of them would go in the treatment group, the other half would go in the control group. The treatment group would get the classical music lessons. The other group should get either no special treatment at all, or maybe some treatment to replace the classical music lessons, but one that we really wouldn't expect would influence academic outcomes. Finally, we'd want to implement the principle of replication. The groups should be relatively large and of about the same size. Generally speaking, you need about 30 or more in order to begin making many of these kind of practical conclusions. And then you would compare the average grade improvements, say, between the two groups. If the treatment group's average grade improvement were to be substantially greater than the control group, that would be a reason to conclude that the treatment, the classical music lessons, probably caused improved learning. The logic is simply this: everything is the same for the music except for the music lessons. So the only factor that's available as a cause is the presence or the absence of the music lessons. All other factors would be randomly distributed, and if the groups are large enough, we would not expect those randomly distributed other factors to affect either group much more than one group much more than the other. So what's the answer to that? Does Mozart make you smarter? Well, there are several observational studies, but no quality large-scale experiments that I know of, at least. It seems particularly unlikely that merely playing Mozart's music around pregnant women and newborn children could substantially increase IQ all by itself, despite the baby Einstein hype. There is abundant evidence, however, that depriving children of good stimulation limits their mental development. So Mozart's music is probably good for children, but it's good in a general way. It's positive stimulation in general, not just classical music in particular, that matters for the mental development of children.